What I'd normally do is we'll set the frequency on receive, but first of all, unfortunately, it's got a dry joint somewhere causing the radio to be deaf as a post. Now I can't spot this dry joint, and what we have, and I don't even know how to say this to you all, but for the last 15 years each of these test benches has what is sold as a therapeutic massager on the bench. I'm not going to get this onto the video except wrapped in paper, but I'm going to switch this on and you will see what happens. Hopefully we'll find a dry joint. And it is in that vicinity. You can hear that coming and going. There we go. So now I can track down the dry joint having used that implement. So I'll get back to you in a moment. So having got rid of the dry joint, switch the modulation off on the signal generator. I've set up our 455 kHz marker oscillator. I'll just put that somewhere in the vicinity of the IF. And hopefully we'll be able to hear that musical note, which is very high pitched at the moment. So I'm adjusting CV2. And there we have it, it's nullified. So that means the receiver's on frequency, say we're on channel 20, so it's 27.79125. We've put the 455 kHz marker oscillator on, so setting it on frequency, there's only the 10.695 left, so to speak, to beat, and that is that musical note which you heard nulled. So that's back on frequency. So switch that off and go through the normal adjustments of the receiver. I'll put the tone back on the signal generator, 3 microvolts. Got a Synad meter connected to an oscilloscope. And first of all, it's the L18, I think it is. And I think that'll be L18. L1. Get that soldering iron on there, it's a bit stiff with the wax. Put it in signal generator to an S9 equivalent, which is 100 microvolts. And then looking at the oscilloscope for maximum recovered audio. This is sine wave, so I'm looking at the maximum recovered audio from L5. That's the detector set. The other IF one on these. Come back to Synad meter. So we'll just see what we're left with. Hmm. 0.6 of a microvolt. See whether we can, off video, I'll just go through that again, see whether we can improve it. And the answer is a bit. That's 0.3, 0.25. So that's pretty sensitive. Now, going back to S9, we need to set the signal meter. I'm presuming the only preset we haven't been through is that one there. So I'm presuming that's a signal meter. And we're looking for S9 on the meter. So with a 100 microvolt signal in place, we need to set that for 9, which is there. And like with the DNT, it's got a local DX RF gain switch. And as you can see, that just dropped a tad with that in position. Let's drop the signal. That's a bit more noticeable when it's only an S1 signal. Right, we'll check the squelch control out. Switch the signal generator off. Squelch the threshold. Signal generator back on. Comes in at 1 microvolt. Squelch to full. Comes in at 3 microvolt. You'd say that was quite a weak squelch, but they're not adjustable, and that works as well as you would expect for this kind of set. You're probably aware that the DNT M40 and the LCL 2740 have quite poor receive selectivity, so they're prone to what is regarded as bleed over. Which you'll notice on that M40, it had been modified to have a crystal filter, whereas we've got the what a friend of mine used to say, the lump of mud ceramic filter just there, which is how it should be. That's how originally it was. But they were the DNTs were batch modified at, it'll come to me, another business radio, a very famous business radio organisation, Cleartone, to bring the super tuned version of the DNT. Now, that never happened with the LCO 2740s, but you come across some which have been retro engineered by local radio engineers to put a crystal filter in there and thus improve performance. And that will also improve the squelch on these type of radios, which is again pretty abysmal. So just to recap, what we've done there is to set the frequency using a 455 kHz marker oscillator with CV2 there, and you can also use that on the 10.695 marker oscillator if that suits you better. And then we've gone through the lineup, which is basically L1, L2, L3 and L4, with the detector being L5, and then the RF meter is S9 set at 100 microvolts with that preset there. So there you have it, the LCL 2740. Going back to that therapeutic massager, which I certainly wasn't going to show you, when I was manager at Nottingham Radio for many years, the co-owner there, whose name was John, still is John because he's still running, he introduced me to that technique. And it's funny how you don't cover these kind of things at college, but when you're actually out in the field, there's some really good shortcut techniques. And these radios can be riddled with dry joints. They're a double-sided printed circuit board, and if I just zoom in on a typical point here, you've got a resistor there which is soldered through the printed circuit board. And so it's soldered both sides. And that's important because this side, the boards aren't plated through. The only way that the signals get from one side to the other is by them being soldered through. So if you get a dry joint on this side, it can be quite a swine to find. It turns out that with that massager I used, it was a dry joint somewhere around here, around the IF section, on the other side of the board. But they can be very, very difficult to spot, and that's a good shortcut. So there you have it, the LCL 2740. And when the other Richard turns up at the weekend, and it's Friday today, and so he'll turn up tomorrow, we'll do an on the air video with both these sets, and then you'll see how they perform or they don't. So there you go, the LCL 2740.